Right. Word problem for sinusoids. Ferris wheel at the Comal County Fair is a 3-minute ride that takes its riders on a thrilling ride up to a maximum height of 105 feet and a low point of 5 feet. Assuming the Ferris wheel rotates at 4 revolutions per minute and a rider starts his stopwatch immediately as his ride starts at the low point, do the following. Sketch the graph of the rider's height above ground in feet as a function of time t in seconds since the rider started his stopwatch. So we've got a lot going on here. All right, so we've got a max height of 105 and a minimum of 5. And our minimum is 5. So that means the maximum and the minimum are 100 apart. So the amplitude is going to be half that. So the axis is right in between. So we have a difference of our max and a min of 100, which means our axis is the midpoint between the two. And the midpoint between 100 and 5 is 55. So our axis, y equals d, is at 55, right in the middle. The amplitude is the distance from that axis to the 105 and from that axis to the minimum of 5. So those are 50. So our amplitude is 50. All right, period. Says somewhere in here, wheel rotates at 4. Let me get a different color. 4 something. It's a problem with split screen. 4 revolutions per minute. Okay. So this is what we're going to use to get our period. So we know we make 4 revs in 1 minute. But if we read how we're supposed to sketch the graph, we are sketching the graph of his height as a function of time t in seconds. So I need to get this into seconds. So 1 minute, 60 seconds. So what that gives us is 4 revolutions in 60 seconds. If we reduce that, that gives us 1 revolution in 15 seconds. So if we make 1 revolution every 15 seconds, period is 15. All right, so now that we have the period, we can go get our count by so we know where to put our tick marks. Count by is 1/4 p. So 1/4 of 15. And because it's time, to me it makes a little more sense since it's not going to be an ugly fraction. I would do this in decimal form. Just because it's time, it makes more sense. We don't like to say 5/2 of a second. We like to say 3 point whatever seconds. All right. So I believe we are ready to get a graph going. All right, let me get a bunch of tick marks. And the reason I got the calculator up is it got to have the calculator to get through these calculations once we get the graph and equation created. Come on, cooperate. Copy. All right, that should be good. All right, let's see. When did he start? He started his stopwatch as his ride starts at the low. So that means I can go ahead and put my axis here. We said the minimum was 5. I'm going to bump it up just a little bit so that it's not running into everything. Let me have another one. Just a touch. There we go. Okay. All right, so we said 5, 55, lots of 5s, 105. So this is the height. I like labels, so I'm going to label. This is our time and t. All right, let me get all those critical points on there. So he started at 0. So from 0, we know he's at the low. So then we would be adding our count by to get all our tick marks. So our count by is 3.75. So our first one is going to be 3.75. And then we're going to do 3.75 plus itself. That gives us 7.5. And we add another 3.75, and we just keep on doing this until we run out of tick marks. 11.25. Another. And another. Just keep on going. Okay. A lot of tick marks. All right. I'm going to put the axis in. I struggle drawing this thing, keeping it lined up without that axis on there. It just kind of helps. And actually, we're going to, because I did kind of make this long, I'll erase these in them. Whoops. Undo that. Copy. That way I can keep everything kind of lined up. Okay. Like I said, nitpicky details. All right, so he starts his stopwatch immediately as his ride starts at its low point. So immediately means when time is 0, he's at a low. So then from there, he's got to go up. He goes up to his axis. Let's try really hard to get this lined up pretty. All the way up to his high. Oops. Back to his axis, down to his low. Back up. And back down. And this thing continues on. So for this one, notice I didn't really put anything over there on the right, on the left side of the time, because time can't be negative. So it's kind of pointless to show it over there. Okay, I have not zoomed in enough. Like I said, just as best you can. You can see my free hands are pretty shaky. But I can auto make it pretty. No. Loop, please. There we go. Okay, there's our graph. All right, part B, assuming the rider's height is a sinusoidal function of time t, write a particular equation in terms of h of t. So you write an equation. Sine, cosine, it does not matter. Completely up to you. If I look at this graph, I notice a low at time equals 0, so I would do a negative cosine graph. So h of t, I'm going to do negative cosine, so negative 50, because that was our amplitude. Cosine of, I need b. I don't have b, but I have p. So we're going to go real quick calculate b using our period. So the absolute value of b is 2 pi over p, which is 15. So 2 pi 15ths, it doesn't reduce. So 2 pi 15ths. The phase shift with negative cosine is 0, so we don't need a minus anything inside or a plus anything inside. And then our axis D is at 55, so plus 55. So there's our equation. Again, if you don't want to do the negative cosine, you could do positive cosine. You would just have to do a right shift over to 7.5. Totally up to you as to how you want to do this. All right, then it says confirm your results by graphing your equation in your graphing calculator in the window in which you sketched it. So that's what the calculator's for. Most importantly, make sure your mode is in radians or it's not going to come out right. All right, so I'm going to hit y equals. I'm going to type my graph in, negative 50 cosine, get my fraction template, 2 pi over 15, get out of that fraction, type in a variable, plus 55. So there's my equation. My window, I'm going to go adjust my window. So let's see, our x minimum was 0. My x max looks like 30. Oh, come on. Gotta get that. Get the calculator up. Yeah, there's some ads for the back of the truck at Valmart Chevrolet. No, thank you. Oh, so close. And then my y minimum, I'm going to leave it at -10 just so it's not right at the bottom. And then our max is 105, which I didn't quite get. Look at that. I think I accidentally drug that down. So we're going to go, whoops, there we go. Also said I would erase my lines and I forgot to. There we go. 105. The scales, it's totally up to you. I'm not going to mess with them. Then I'm going to hit graph. Look at that. That looks like what I got. So I'm going to say yes. Confirmed. Check. How high above the ground is the rider at time 48.5 seconds? So at time 48.5 seconds means what is h when t equals 48.5? So we're looking for h of 48.5. So a couple ways you can do this. You can go through all the trouble of typing that whole mess into your calculator. It's not necessary. Let me get it written out. Was it 2 pi 50? Yeah, 2 pi 15ths. 2 pi 15ths. Plugging in 48.5 for t. Close, plus 55. So the long way to do this, type all of this into your calculator very, very carefully, and whatever it spits out is your answer. However, I already have this thing in y equals, so I'm going to quit and go to my home screen. Alpha F4, which is your trace button. If you hit Alpha F4 on your home screen and do Y1, open parentheses and type in 48.5, it will plug in 48.5 for your variable into the function of Y1. So to me, that's easier. Oops, I need my pencil. So 49.77, I like 3 decimals, 4. So at time 48.5 seconds, he is 49.774-ish feet above the ground. But then it says, at this time, is he going up or down? So remember that Ferris wheel rotates all the way up, and then it comes back down. So he's going to go through that height twice. So that's where we can use our table to help us. So for your table, the table settings, if you look at your table settings, which is your window button, right next to y equals, I'm going to go second table set. I want my table to start at that value I'm looking for, 48.5, but I want it to count by something very, very small. That way I can see those differences in those heights. Then I'm going to go look at my table, second table. So there's our height. We can see the 44.774-ish. And if I look at the next height, it's 0.79, then it's 0.8, and at 0.9, and so forth and so on. So those heights, they're not getting bigger very quickly, but they are getting bigger. So he is at this height, and he is going up. E, at what positive time is the rider 88 feet above ground coming down for the third time? So 88 feet above ground means the height, or h of t, is 88. So what we want to do in here is I'm going to go to my y equals, and I'm going to go down to y2 and type in the height I'm looking for, and then I'm going to hit graph and see if I can see what I need. So it said 88 feet coming down for the third time. So if we look at our graph, I can see that he's coming up for the first time where those two meet, then he's going down. So I can only see the second time. So what that tells me is my X max is too small. So go to my X max, and I need it to be bigger. So I'm going to change it to 60. I'm just going to double it. So now we can see where he is at 88 feet coming down for the third time. So what we want to do is find the intersection. So we're going to find the intersection. So to find that intersection, we're going to hit second calc, and it's option 5, which I'll do in a second, intersect. Just want to get it written down for you. So second calc, option 5, and it's going to take you here, first curve. So the first 2 questions don't matter, first curve, second curve. It's basically saying, is this one of your curves? Yes. Then it jumps lines. Is this one of your curves? Yes. Now you've got to go take a guess. So it's important you get to the correct one. We want the 88 coming down for the 3rd time. So I'm going to scoochie. That is the 88 coming up for the 3rd time. So we want to go over here to where he's coming down for the 3rd time and hit enter. So it says the intersection is at x equals or t equals 39.529 seconds. Right? And then F. During the 3-minute ride, minty, that should say minute, I'll fix that. For how many seconds was the rider above 100 feet? All right, so 3-minute ride. First thing I need to do is figure out how many seconds that is. So 3 minutes. If we've had a little blank on our conversions, just stoich it. There's 1 minute and 60 seconds. So we're just going to multiply by 60. So that's 180 seconds. All right, so we want to know in 180 seconds, how much time was his height above, I think it said above, 100. So first thing I need to do is I'm going to go down to Y2. I don't need that 88 anymore. I need to know 100. So I'm going to type in 100. Then I'm going to go to my window, and I'm going to change this to 180 and have a look at it. And let's see if it's too much. So we can see we got a whole lot going on in there. So that's going to be kind of hard to do because it's very, very hard to see. So I just want to divide this into equal chunks. So if we have 3 minutes, I could easily just figure out 1 minute and multiply it by 3. So I'm going to go back to my window and I'm going to change that to 60 because I can see the 60 better. And I'm going to work with it there. All right. So we can see there's 4 little bitty sections where the rider is going to be above 100 feet. So if I can figure out the difference in those two, there's 4 times in 1 minute. So 4 times per 1 minute. And remember, he's on this thing for 3 minutes. So that means there's going to be 12 times in 3 minutes. So if we can find the total time of one of those little loops, we can just multiply it by 12 and we'll have our answer. All right, so another thing I'm gonna do, just because I want it to be easy for you to see, my Y minimum, I'm gonna go cut it off. Let's go with 55. This ad keeps inching up on me. Just so we can see a little bit better, there we go. All right, so I need those intersections. So I'm going to focus on the first one. So second trace, 5. The first curve, second curve do not matter. It's when you've got to go play the guessing game. So we're going to need 2 points here, and we're going to need to save them. So I'm going to do the lower bound first. So I'm on that lower end, and I'm going to hit enter. So my lower value, so I'm gonna, for notation, I'm gonna put h of t equals 100 at, and I'm gonna call this time A because it's the lower one. Time A equals 6.423-ish. Now you could use that decimal. I'm gonna do it correctly and store it. So if I go to my home screen, my variable x, when I hit it, notice it's that number I just found. I wanna save it, so I'm gonna do X stow alpha A. Stow, S-T-O with an arrow, is right above on. So I'm going to take X, and we're going to stow, and then you hit alpha A. And what that does is that saves that number as the A key. So then I can go calculate my other time. So I'm going to go back to my graph, and I'm going to go calculate the other point, which is the top part. So I'm just going to scoochie just a little bit. I need that top one. So then we've got time B, which is 8.576-ish. And then we're going to do the same thing, but we're going to do B. So then we're going to go X stow alpha B. So I'm going to go to my home screen. It doesn't like to quit. X stow alpha B. So now I have them both saved. So the total time spent above 100 feet, we said there's going to be 12 intervals, is going to be 12 times that time B minus that time A, which is the amount of time of one of those little intervals. And we can type it in like that, 12, open parentheses, alpha B minus alpha A. And it will calculate it all for you. So 25.842 seconds in 3 minutes is spent above 100 feet. So a little nitpicky on the calculator stuff. I do like to show y'all how to do this because you may need it down the road if you've got to go a little bit higher in math. You probably won't need that last part for some of the word problems in here though. That's just a little bit extra, but it is good to know how to do these calculator steps. I think that was the end of the problem.